Have you ever wondered why your computer sometimes feels super fast and other times painfully slow? You open too many tabs in Google Chrome, start editing in Adobe Premiere Pro, maybe even launch a game like Minecraft, and suddenly everything freezes. You might think your CPU is the problem or your storage is full, but in many cases the real hero, or the real bottleneck, is something called RAM. RAM stands for Random Access Memory, and it acts as your computer's short-term memory. A simple way to understand it is to imagine your computer like a study setup. Your storage drive, whether it's an SSD or HDD, is like a bookshelf where all your books are stored. Your CPU is like your brain, and RAM is like your desk where you place the books you're currently using. When you open a program, your computer does not run it directly from storage. Instead, it copies the program from storage into RAM, and then the CPU accesses it quickly from RAM to process instructions and send results back. This happens because RAM is dramatically faster than even modern SSDs, and that speed is critical for performance. RAM is designed specifically for speed rather than long-term storage. It does not permanently store data and loses everything when the power is turned off, which is why it is called volatile memory. The moment you shut down your computer, all data inside RAM disappears. To understand how RAM fits into the bigger picture, we need to look at the memory hierarchy inside a computer. At the very top are the CPU registers, which are the fastest and smallest type of memory. Next comes CPU cache, which is slightly slower but still extremely fast. After that comes RAM, and finally storage devices like SSDs or HDDs, which are much larger but slower. When you open a program, it moves from SSD into RAM, and frequently used data may then move from RAM into CPU cache for even faster access, while the CPU uses registers to perform the actual calculations. This layered design ensures maximum efficiency and speed. However, problems begin when RAM becomes full. When that happens, the operating system, whether it is Windows 11, Ubuntu Linux, or Mac OS, starts moving some data from RAM back to storage in a process known as paging or swapping. Because storage is much slower than RAM, this causes noticeable slowdowns. That is why having too many browser tabs open, running heavy software with limited memory, or gaming on a system with low RAM can cause lag and stuttering. RAM size directly affects multitasking performance. For basic tasks like browsing and document editing, 4 GB might work but can feel limited. For everyday use, 8 GB is generally comfortable. For gaming, video editing, or heavier workloads, 16 GB is often ideal. Professionals working with virtualization, 3D design, or advanced video production may benefit from 32 GB or more. The more demanding your tasks, the more RAM helps maintain smooth performance. There are different types of RAM as well. The most common type, used as main system memory, is DRAM, or Dynamic Random Access Memory. A faster and more expensive type called SRAM, or Static Random Access Memory, is typically used inside the CPU for cache memory. Modern computers use DDR memory, which stands for double data rate, with current generations like DDR4 and DDR5 offering improvements in speed, bandwidth, and energy efficiency. In real-life scenarios, imagine running 20 browser tabs, editing a YouTube video, playing background music, and running antivirus software, all at the same time. Each of these tasks occupies space in RAM. If your RAM capacity is small, your system struggles. If it is larger, your computer handles multitasking much more smoothly. It is important to understand, though, that adding more RAM does not increase the raw processing power of your CPU. RAM improves multitasking and reduces slowdowns caused by swapping, but it does not make a weak processor powerful. Finally, at the hardware level, RAM is built from tiny memory cells made of transistors and capacitors, where each cell stores a single bit as either a charged state representing 1 or an uncharged state representing 0. Because capacitors gradually lose charge, DRAM must refresh thousands of times per second, which is why it is called dynamic. In summary, RAM is your computer's high-speed working memory that stores active programs and data, works closely with the CPU and storage, improves multitasking performance, and plays a critical role in overall system responsiveness.